This video is on finding factors and the greatest common factors of numbers. If you remember from class, factors are the numbers that you can use to create your number. Think of them as the building blocks that you can use to create a number. So the factors of 18 are the numbers that you can multiply together to get 18. So it's easy to think of them in pairs. We could do 1 times 18. We could do 2 times 9, and we can do 3 times 6. Those are all the factors of 18. Then we take a look at 30. And we think about what could I multiply together to get 30? Well, I can always do 1 times 30. I can do 2 times 15, 3 times 10, or 5 times 6. And you can always use your multiplication table if you need some help trying to figure out what is it that I could multiply together. Now, the problem asks me to find the common factors, meaning what factors do they both have? Well, they both have a 1, they both have a 2, they both have a 3, and they both have a 6. So they have a 1, 2, 3, and 6 as common factors. Those are numbers that I could use to create an 18, and I could also use them to make a 30. Next, we want to find what's called the greatest common factor. That's the largest factor, the largest number that can go into both numbers. If I look at the previous problem, my greatest common factor was the biggest factor they had in common, in this case, 6. So one method we talked about in class to find greatest common factor was simply list out all the factors for both numbers, and then compare the two lists. What's the biggest number that shows up in both lists? Now let's find the greatest common factor of 42 and 60. And this time we're going to use our factor trees. That was our other method for finding greatest common factor, dividing our number down into its prime components. So we start with 42 and we ask ourselves, what could we multiply together to get 42? Well, I can make it into a 6 times 7. You could also have done 3 times 14 or 2 times 21. You'll all still ultimately get to the same final answer. It doesn't matter what pair of factors you choose to start with. Then we look to see if we can continue branching out. With 6, I can divide it farther. It can become a 2 times a 3. For my 7, I can't divide 7 any farther. It's a prime number. It doesn't have any factors other than 1 in itself, so I have to stop there. Same thing with my 2, and same thing with my 3. They're down to prime numbers, so I can't go any farther. So I ended up with 2 times 3 times 7 as my prime factors. If I did 2 times 3 times 7, I would get 42 again. Now I do the same thing with 60. So let's go with 6 and 10. Again, you could have done 2 and 30, or any other combination that would give you 60. Eventually you will end up with the same prime factors when you're all said and done. I keep dividing. 6 becomes a 2 and a 3. 10 becomes 2 and a 5. Basically, we're dividing them into a pair of factors that could be multiplied together to get that number. In this case, my 2, my 3, another 2, and a 5 are all prime numbers. They can't be divided any farther. So I ended up with 2 times 2 times 3 times 5. My ultimate goal is to find the greatest common factor. So now I need to look at what prime factors do they have in common. In this case, they both had a 2. They both had a 3. So I take that 2 and I take that 3. I multiply it together and get a greatest common factor of 6. That's the largest number that they both have in common for a factor. So let's try again. Here I have 25. Well, 25 is 5 times 5. 5 and 5 are both prime numbers, so I can't go any farther. And I get 5 and 5 as my factors. For 15, I can do 3 times 5. In this case, both of these trees are going to be pretty short because both 3 and 5 are common factors, or are both prime numbers, excuse me. Now I compare the two lists. What factors or factor do they both have in common? Well, in this case, they each only have a 5 in common. So 5 is my greatest common factor. So you can either use the first method, listing out all the factors of both numbers, and then comparing the two lists to find which one is the largest, or use your factor tree. Divide the number down into its factors until you get to prime factors. Compare the two lists and use those common factors to create your greatest common factor. Good use of factors is in helping us simplify a fraction. Remember, when you're trying to simplify, 45 divided by 3 gives me 15. Then I look at 14 and 15. Can anything more be divided? Well, neither one of those have anything else in common, so it's in simplest form. There's nothing that both 14 and 15 can be divided by. So let's try the last one, 32 50ths. So again, I look at 32 and 50 and I ask, what can they both be divided by? Well, in this case, let's try 2. So I'm going to divide each one of them by 2. 32 divided by 2 is 16. 50 divided by 2 is 25. Then I look to see, can I divide out any more? In simplifying fractions, sometimes you can do several rounds of dividing before you've divided out all the common factors. In this case, 16 can be divided by several things, but unfortunately none of them are the same that can go into 25. So they don't have any other factors that they both have in common. So my answer is 16 25ths. And that's how we use factors to help us in simplifying fractions.